Hey friends. Okay, so today's our first lesson of the unit price and currency exchange. Um, I'm hoping that you're going to feel like we're easing into things. I'm hoping this one's not going to be too stressful on you. A lot of it will come from your days of junior high, but it's a great lesson to start with just to make sure we're on the same page and just to make sure you're feeling super confident, right? That is the goal of Math 10-3 is we want you guys to feel really confident about what you're doing. So let's give it a go. Okay, so what is a ratio? A ratio is used to compare two numbers that have the same units. Now, it doesn't matter what that unit is. That unit could be centimeters, or it could be meters, or it could be kilograms, or it could be pounds. Whatever it is, both items that we're talking about, we're talking in that same unit. Okay, so the example I've given here is rice. To cook rice, the ratio of rice to water should be 1 part rice to 2 parts water. And just like I said, the parts could be cups, or they could be liters, or they could be even gallons. That's a lot of rice. You will not be hungry for a long time if you cook a gallon of rice. But if you did want to cook 1 gallon of rice, you would need 2 gallons of water to go with that rice. Okay. So the units have to be the same. Okay, so ratios can be written in words. Now that was what I just did, right? We said 1 part rice to 2 parts water. Or we could use a colon. A colon is, let me just put my ink on here. A colon is those dots like this when we have that. Okay, so we could go like this, 1 to 2. Okay, do you notice when I said that, I also said 2. Okay, we say 1 to 2. Okay, or as a fraction, like so. Okay, if you choose to write it as a fraction, never write it as a mixed number, always as an improper fraction. Now let's just review that for a sec, make sure you're comfortable with that terminology. A mixed number is when there's a big number in the front. So say I went like this, 5 and 1/2, okay? Instead, we want to write it as an improper fraction. Now, an improper fraction just means that the numerator, the top part of my fraction, is larger than the denominator. So it's just another way of representing a number that's bigger than 1. You might remember from your junior high days, you might not, it's totally fine. But if I took 5 and times it by 2, because I know I have 5 wholes there, so 5 times 2 is 10 plus 1. This is the same as saying 11/2. Okay, so the mixed number is the 5 and 1/2. The improper fraction is the 11/2. Now, I do find lots of kids come to grade 10, they come from junior high and they say, oh, I'm not allowed to write as an improper fraction. Maybe that's because the word is called improper and we think, oh, if it's improper, it's not supposed to happen. Actually, in math, there are many times where we would prefer you writing as an improper fraction. So don't get scared if the top number is bigger. It's okay to leave it like that sometimes, okay? Especially in a ratio. So the numbers and the words for a ratio are always in the same order, okay? The order that I originally talked about was rice to water. Okay, so if I say 1 to 2, that 1 is going to refer to the rice and the 2 will refer to the water. The numbers have to be placed in the same order as the words did. Okay, so in this case, since we said it was the ratio of rice to water, if we choose to write it as 1 to 2, the 2 must refer to the water because it came in second. Okay, so class example, write the ratio 1 part rice to 2 parts water in multiple ways. I actually did this on the previous slide when I was talking about how to write them as a colon and how to write them as a fraction, okay? So here's the colon, 1.2, and here's the fraction, 1/2, 1/2, okay? All right, whether written with the colon or as a fraction, we always want ratios to be written in simplified form. Now, this is going to go back to your junior high days when you dealt with something called reducing fractions, if you remember how to do that. Okay, if we have large numbers, like, I don't know, let's put my ink on here for a sec so we can think out loud. Let's talk about 10/12. Okay, you'd want to look at 10/12 and say, hey, I could divide both of these guys by 2, and that would reduce this. 10 divided by 2 is 5, and 12 divided by 2 is 6. So saying 10/12 and saying 5/6 is the same thing, okay? this is the nicer way to say it, just because the numbers are smaller. The same thing works with ratios, okay? If I had said 10 to 12, I would want to say, okay, I can divide that by 2, and that would be 5, and I can divide that by 2, and that would be 6, okay? Okay, so this means we want to divide each term by the same number to make the numbers as small as possible. It also means that if we have a decimal, we don't like decimals, so we're going to multiply both numbers so that we end up with whole numbers for each of them. And I'll show you how to do that in an upcoming example, okay? All right, so class example number 2, we're going to simplify or reduce the following ratios to lowest terms. Now, let's start with the 30 over 45 that you see. Okay, so I need to find a number that when I look at these guys, I can divide both of them by that number, okay? You may right away say, oh, I know, it's 5. Okay, let's try that. Let's go divide by 5, divide by 5. So 30 divided by 5 is going to give me 6. And 45 divided by 5 is going to give me 9. And that's perfect. That is a great simplified version, okay? But we're not quite done. We're not fully simplified because I can look at the 6 and the 9 and say, oh, I can divide both of those guys by 3. When you're trying to reduce, you're always trying to divide. Anytime we talk about equivalent ratios or equivalent fractions, we're looking at multiplying the top and the bottom by the same thing or dividing the top and the bottom by the same thing. We're never ever looking at like adding the top and the bottom or subtracting. Those don't work, okay? They don't make equivalent fractions. Okay, so 6 divided by 3 is 2 and 9 divided by 3 is 3. Now, some of you may have said, oh, but what if I had seen that I could have divided both of those guys by 15? Okay, if I divide by 15, divide by 15, 30 divided by 15 is 2, 45 divided by 15 is 3. So I get the same answer. Doesn't matter. Which one's better? That's a great question that you ask. Whichever one you see first, okay? Lots of kids get in their head, oh, I have to find that biggest number, so I do it in one step. Well, if it takes you 5 minutes to find the biggest number, but you can find 2 smaller numbers in 2 minutes, then actually working with the smaller numbers is probably the better option, okay? Do what naturally your brain feels comfortable doing, okay? Okay, let's take a look at the 15 over, sorry, not over, 15. I was trying to change the ink color at the same time. That's why I said over, I wasn't paying attention. 15 to 20, so both of these are divisible by 5. So if I divide 15 by 5, I would get 3. See, now I have a pretty blue. 20 divided by 5 is 4. And I look at those two numbers. 3 to 4 is the reduced ratio of 15 to 20. And I can't go any further. Okay, those are as small as I can possibly get. Okay, awesome. All right. Now, let's have some trail mix. I'm just going to hide my face here for 1 sec just to make sure you can see the ingredients there if you don't have your little booklet in front of you. Okay, so a trail mix recipe contains the following ingredients. So we've got 2 cups assorted nuts, 1 cup dried fruit, half a cup raisins, half a cup of Cheerios, and 4 cups of pretzels and 1 cup of chocolate chips. Really, the most important ingredient there is the chocolate chips. Trail mix isn't trail mix if there's no chocolate. Okay, what is the ratio of assorted nuts to pretzels? So we just find that right off of our list, okay? So assorted nuts, I have 2 cups of those. Okay, so I have 2 to something. And then the pretzels, I have 4 cups of pretzels, so I end up with 2 to 4. Okay, then I think, okay, can I reduce that? Yes, both of those numbers are divisible by 2, so 2 divided by 2 would give me 1, and 4 divided by 2 would give me 2. Okay, so my final ratio there would be 1 to 2. Remember that the nuts went first, the pretzels went last, so the number that represents the nuts goes first, the number that represents the pretzels goes last, okay? Okay, how about the ratio of raisins to chocolate chips? So I've got half a cup of raisins, and so I'm gonna write, let's write 0.5 there for now. And then I've got chocolate chips, 1 cup of chocolate chips. So I'm gonna go to 1 like that. Okay, now we've already talked about the fact that we don't want a decimal there. So there's a couple different ways we could do this. Some of you may say, hey, if I multiply 0.5 by 2, I would get a 1. So that's one way to do it. We could go, okay, 0.5 times 2 is 1, and 1 times 2 is 2. Beautiful. Okay, now some of you might be listening to this video getting very stressed out and saying, how was I supposed to know that 0.5 times 2 would give me 1? It's okay, you don't have to. Watch what I can do. I can take my decimal and just move it over 1. Okay, and that would give me the number 5. Okay, if I do that to the left side, I have to do that to the right side. So right now my decimal is here, it's behind the 1. So if I move that over 1, my decimal's here now, which means I got to put a 0 in that hole. And so that would be 5 to 10. Then I can look at 5 to 10 and say, okay, can I divide both of those numbers by something? And the answer is sure I can. I can divide them both by 5. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So I still get to 1 to 2. Okay, what is the ratio of dried fruit to total ingredients? So dried fruit is 1 cup. Okay, so 1 to something. Now, the total ingredients, you have to include the dry fruit in there, okay, because they are part of the total. So all of those are the total. So let's add those up together. I'm going to make this friendly. I'm going to add the 1.5 with the half right away, because I know that that makes 2, and then I don't have to deal with fractions. So that's 2 here. Cross those off because I've dealt with them. Then I got another 2, so I'm at 4. Then I've got 5 and 6, and then I have to add 4. So that means there are 10 cups of total ingredients. So it's going to be 1 to 10. Okay, 1 to 10. All right, you guys are doing fantastic. Let's see. I'll just throw the answers there. We already talked about them. Now, if you are with me in your unit booklet, I'd like you to now pause the video and try the on my own number 1 to 4, okay? At the back of this lesson, not the whole book, but just this lesson, we've given you answers for all of the on my own. So you try 1 to 4, flip back, make sure you're getting the right answer, okay? And then when you're done with that, unpause the video and come join me again. Okay, awesome. Hopefully 1 to 4 went really, really well for you. Now we're going to shift our attention and just talk about rate for a second. Rate is very similar to ratio. The big difference is the 2 items that you're talking about don't have the same units anymore. Okay, so speed is a great example. Okay, if you're traveling on the highway, you're traveling 100 kilometers an hour, probably, maybe 110. Maybe if your parents have a speeding problem, you're going 130. I don't know. But anyway, whatever the speed is, you're going 100 kilometers per hour. Okay, 100 kilometers per hour. So there's 2 different units there. We're talking about the kilometers that we're traveling and then the time, the hours that it takes us to travel at. So a rate is a comparison of 2 or more quantities measured in different units. For example, the posted speed on the highway is 100 kilometers per hour. The per that you see there, not talking about what a happy kitten does, the per is a division line. So we would say like kilometers per hour. It would look like that. Okay. Units must be present in a rate because they're different. We have to state them. Okay, so write a rate statement for each of the following. 9 milliliters in 2 seconds, okay? Now, that is sort of like a rate statement already, but what we're going to do is we're going to write it so that we can say milliliters per second, okay? Milliliters per second, that means that we want 1 second. So all we have to do is divide 9 by 2. So I'll go 9 divided by 2, and that's going to give me 4.5 milliliters per second. Okay? What if I went 170 kilometers on 6 liters of gasoline? Well, I want to know my rate in kilometers per liter. So I'm going to take the kilometers and I'm going to divide by the liters, right? Remember that per talks about division. So 170 divide by 6. You don't have to do this in your head. You can grab a calculator to help you, okay? 170 divided by 6. And that's going to give me 28.3 kilometers per liter. Now that's a slightly rounded value. That's okay for now. We're just trying to get, I didn't give you rounding instructions, but we're just trying to get comfortable with what we're doing. 32 meters squared in 6 hectares of land. So I want to write that as meters squared per hectare. I'll go 32 and I'll divide by 6. And that's going to give me 5.3 meters squared per hectare. Okay. Remember, you have a pause button available to you whenever you want it. So if you find these questions going too fast, you should never just watch me do something. You should pause and try it yourself. That's how we learn, right? We learn by actually trying to write it down, figuring it out ourselves. So keep pausing me, shutting me up for a second, try it, and then come back. That's the best way to use these videos, okay? Okay, 0.96 for 5 oranges. Again, we want the unit price per orange. This is something we're going to talk about a lot in a few lessons because we're going to try and figure out better deals and stuff like that. But for now, we're just going to take that 0.96 of a dollar, 96 cents, and divide by 5. Okay, and that's going to give us approximately 19 cents per orange. Okay, 19 cents per orange. All right. Awesome. So now we're ready to go back to some on my own questions. It would be question 5 to question 7, just 2 more questions. Again, try them, check the answers in the back of the book, okay? And connect with me if you have any problems, because that's actually going to finish our first lesson. So way to go, you guys. You made it through the first one. And now in the next lesson, we're going to take this just one step further and talk about proportional reasoning, okay? So I will see you there. As always, if you have any questions, make sure you come and chat with me, okay? That's what I'm here for. You got this, guys. Take care.